Today, decarbonizing the entire U.S. economy in 15 years. Welcome to the Clean Power Hour. I'm Tim Montague, your co-host. I'm joined by my co-host, the commercial solar guy, John Weaver. Welcome to the show, John.
Hey Tim, how are you today? It's blue skies outside, so I'm in a great mood. It's just the way things start when it's pure blue skies.
We're having such a lovely August here in the Midwest, and I know I was talking to my family the other day, who they're all on the East Coast. Sounds like you're having nice weather there too. So I'm glad I don't live in California. We're sorry to hear about all the fires, and we're going to talk about that here shortly in California. And I almost went there in the pre-show, but I had an aside related to fires. It seems very distant when when it's on the other side of the country, but I did live in San Diego for 10 years. I went to UC San Diego as an undergrad, and then I moved there as a young professional after getting married and living in Norway for a few years. And we had a medium fire season one year. This was around 1999, 2000. 2001, can't remember exactly, but we were driving on the 5, which is a major north-south highway from San Diego that goes all the way up to Northern California. And literally we saw the fire jump the highway. Although before we saw the fire, we saw cars driving the other way on the side of the highway that we were on. People were just turning around and driving the other direction, south in this case. And then as we continued north a little bit, then we saw the fire jumping 8 lanes of freeway. So it's extremely dangerous and volatile, and our hearts go out to all of the Californians that are dealing with not only the fires, but the rolling blackouts now. So what's the story though, from your angle, John?
Well, with California, they have a lot of challenges. I mean, they have the hottest temperature possibly measured on Earth, at least in the last 100 years. Even Arizona now, because of the same heat wave, is projecting rolling blackouts. So that whole, southwestern region is bearing consequences, and they're dependent upon each other. So it's something to think about. It gets me a bit more sober. I've never lived in Cali. I've built a few projects in California, and right now I'm literally working on a project whose purpose is to back up a water district, the Yucaipa Valley Water District, and we're adding solar storage, and so that the water resources can stay online during fire events. And it's just sobering. You speak to these human beings every day, and you're working hard to get through a project. And then you see this stuff on the news, and you've heard about what's happened in the past. And this site, literally, when I visited, had a burn to the south of it. Its south fence, the south property line, was burnt. And, you're working on real projects with real human beings, and we're literally trying to secure the water supply. And so it just I hope everybody at the Yucaipa Valley Water District's safe, and just know that we're working as hard as we can to do our part. So it's something.
Yeah. And there has been some back and forth about, well, what's the cause of the blackouts, and that is still TBD, I think. But there's an investigation going on whether the blackouts are truly necessary and what is causing these. In theory, the grid only has so much power generation capacity, and it is possible when you have a heat wave that you exceed that capacity, right? There's just not enough power plants on the grid to feed all those air conditioners. But it can also be that people are prematurely pulling the trigger because they're paranoid, or other reasons. Back in the early 2000s, when I was living in San Diego, they were rolling brownouts, and then after the fact, it was determined that that was a scandal, and the utility didn't need to be doing that, but was doing it to game the system. And I don't fully understand what it was that they were trying to achieve. But that's pretty dark stuff when you're pulling the plug on people's businesses in the middle of the day unnecessarily. So we are dependent on the grid, and we want a safer, more reliant grid, more reliable grid, which is why renewables are such a wonderful thing. When you pair solar storage and wind, you do produce a very reliable grid. Obviously, we also have to upgrade that infrastructure, the wires. And I wanted to, that's a nice segue, I think, to this initiative called Rewiring America. And I'm going to share my screen here. This was a story that I learned about from a couple of other podcasts that I listened to, namely The Energy Gang with Stephen Lacey and Jigar Shah. And so if any of our listeners aren't familiar with that show, check that out. That's a wonderful, I think it's weekly, but they're cranking out the content. And Stephen Lacey is affiliated with GTM Media, so it's a co-production of his and GTM Media's. But anyway, we're looking at the Rewiring America website. Some very smart people got together, similar to the plan that I covered to decarbonize the grid. But this is an analysis of decarbonizing the entire U.S. economy. And they have produced a couple of reports, a jobs report called Mobilizing for a Zero Carbon America, Jobs, 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 and More Jobs by Saul Griffith and Sam Calish. I did a little research on this guy, Saul Griffith, very interesting guy. He's a MacArthur Fellow, or MacArthur Genius Award recipient. He's a very smart engineer from Australia originally, so he's an immigrant. America is built on immigrants. My family immigrated from Ireland, a couple generations ago on my mom's side, and then from England in the 1600s on my dad's side. So we're all from somewhere else. We have to remember that, and that makes us stronger, not weaker. I'm a huge fan of immigration because that is the reality. We all came from somewhere else. Even the Native Americans that were here before the Europeans came from somewhere else, right? So that doesn't defend what we did to them by stealing their land. But anyway, so this report basically, they took a bottom-up approach. They didn't say, well, let's what does it take to do something by 2035? They said, let's just analyze the economy soup to nuts, and using existing technology, using existing equipment and technology, like you and I work in the solar industry. There's solar, wind, battery storage for the energy sector. And they looked at the four major sectors, industry, transportation, energy, and the built environment. And they said, we want to get all the carbon out. How do you get carbon out of transportation? Well, electric vehicles, of course, for automobiles and trucks. And then for aviation, you use biofuels. So you can do net zero biofuel production using electric tractors and then growing crops that you then convert into biofuels. That's not super efficient, but it's way better than creating climate chaos. And what this is going to take is $3 trillion. So it's $300 billion a year for 10 years. And so it is a big investment, but it's going to create 25 million jobs. And it's going to save consumers $1,000 to $2,000 per year. And of course, it's going to save us a lot of money, because this is truly the only way to step back from climate chaos, right? Is to vastly reduce our carbon footprint. And, that awareness is now mainstream, John, that society is facing an existential threat from climate change and global warming. And it's very hard for us humans to grok the scale, the magnitude of that problem, right? We are short-lived animals. We live, if we're lucky, 80 to 90 years. And, so we're good at thinking about things on a year or two scale. And now we have to think of things on 100-year scale, because my kids and their kids are picking up some really tattered pieces, as you know, we see the droughts, the storms, the fires, and the floods. It looks like we're going to have a record hurricane season. I don't know if that's something that is on your mind on the East Coast there, but it sure seems like it's going to be a record year for climate disruption.
Every year is going to be a record year coming out. That's just the nature of where we are. We're in a time of change, and going forward, like all times, change is the true only constant. But right now, we're going to see some changes in areas that weren't changing, and weather will be one of those. Our energy infrastructure, how we travel, how we look at things. There's just going to be a lot more judgment calls, and that's why I'm in the solar industry. I mean, that's literally part of it. I made a judgment call about what I wanted to do with my life and said, okay, this looks like a thing that needs to be done by us. So that's an interesting report. And, you know, these reports, I'm always interested in browsing them and seeing the job types, because there's always more jobs in energy in varying levels of doing things. And I come to realize, you know, I build stuff mostly, and then I do financial modeling. So from my perspective, I go out to the sites and I work with the guys and the ladies putting hardware in the ground, driving the machines. And then I go back to the engineers and we look at the AutoCAD files, and then I go hang out with the bankers and we do the spreadsheets. And so that's what I see. But there's like layers and layers beyond that. There's, you know, the guys the people we buy hardware from. There's the people in the permit office who are looking at this stuff, analyzing. They're the politicians who deal with the different researchers who are developing the technologies. There's so many layers that come out. So when you see like 15, 20 million jobs, it's like, yes, I know that many jobs, but it's just so hard to comprehend how big. Because right now we've already got 250,000 people in solar, but we're at 3% of electricity is solar. We got to go up like 5, 10x. We're going to have 2.5 million people in solar. And that means you're going to start meeting random solar people on the world, walking around, and random energy people. It's a big thing we're doing. This is our planet. I like when you said it's hard for us to grok the scale. I'm gonna have to, you know, really work that term, but that's truth. That's a real truth.
Yep.
Wow.
So we got a lot of stories we want to cover today, John. We've got helicopters and solar. We've got the world's biggest battery. What would you like to talk about first?
You know, I like the helicopter and solar one first because I get to say helicopters picking up solar panels. That makes me happy. And that's just kind of cool. Because who the heck doesn't want to fly a helicopter and move some solar panels around? That's just neat. But I
Yep.
really, you know, I'm actually thinking about it because currently you know, I have a few projects ongoing, and we have cranes out there, and dealing with managing the site properly so that building owners, business owners who have real life going on. Remember, we're just an efficiency upgrade. We're just a hardware addition to their building. We are not their business. And they got many, many things going on. That's why I'm okay with calling them 10 different times over the course of 2 months to move things forward. That's my job as a sales guy. But here's another piece of it. Another job with me as the construction guy is that I need to make sure that if I'm going to build on somebody's structure, I'm conscious of their parking. I'm conscious of their customers. I'm conscious of them being able to earn the cash that allows them to buy the solar system. And I've never had to deal, hey, would you mind scrolling up just a tiny bit on that so we can see the image fully? I've never had a deal with, no, the other image, the helicopter image, where I've had a complex roof like this with multiple sites that are just hard to get onto. I've always been able to use a crane. Recently, I had to take apart a little bit of a solar system so I could get on a roof because I had 2 systems on it. But dealing with multiple roofs and complex sites, getting these pallets up there that weigh a couple thousand pounds each, that's tough work. We're conscious of it. We develop plans to deal with this. We do our best to minimize the amount of time the crane is on site. You know, if you look at that paragraph right above the popular content, the contractor said extensive traffic management and increase to public and staff. We don't want to do that. We don't want to disrupt the public and the staff, because that's business. And so he ran the numbers and he said, you know what, in this particular strange case, the helicopter helped. And I've never priced a helicopter in my life, so I don't have any idea what it costs relative to the cranes I rent. But this guy ran his numbers, and so at first it's cool. It's a helicopter, man. That's sweet. I want to do a helicopter, but it's also really interesting the project mechanics that had to be determined and gone through to work this site. And contractor picked a helicopter. That's innovation right there. That's pretty sweet.
But so let me see if I just understand this. Traditionally, we're taking a crane and we're craning pallets of material, solar panels, racking, ballast, wire, pipe, etc., and just lifting that kind of one pallet at a time or two pallets at a time. And now, as a way to free up space and I guess just space around the facility, right, that would otherwise need to be a staging area for all of that stuff. You can use a remote location for a staging area, and then use a helicopter to effectively crane this stuff from the ground to the rooftop. And are they doing it very similarly though, like one or two pallets at a time, or are they doing like a shipping container?
Well, the images that I saw here when I poked around a little more, it looked like one pallet at a time. And I actually see a couple of time savers, because a lot of times when you're craning, you only have a certain spot where you're allowed to put that crane. And so there's setup time and breakdown time of a crane. So you grab that one pallet, you put it on the roof, but you can't keep that pallet there. You have to spread these pallets because of point load. So structural weight matters. You can't just put 10,000 pounds of pallet right there. You got to put one here. Then you got to put one over there on that one. And so sometimes the crane can reach these areas, but sometimes the crane can only put it in a spot, and then you have to move it on the ground. And, we put down cardboard, we put down other stuff, plywood, and we slide pallets. And then other times the crane and the areas of the roof just don't connect. So you have to move the crane, and that takes a breakdown and a setup, and it takes delivery people being on there for a longer time. So a remote location where you can just quickly stage and break down items and then move it. That I hadn't even thought about the remote aspect of the staging, just simply the fact that it's a helicopter coming in. So it's, all these different layers of work that take to set up the project so you can actually build, they're non-trivial. And that's just kind of neat.
Yep. So we've got a variety of storage related stories as well this week. And so let's talk about the LS Power story. I'll put that on screen here in a second. LS Power energizes world's biggest battery just in time for California's heat wave.
Yeah, that's kind of neat. So I follow the VP, one of the VPs of LS Power. His name is Cody. I follow him on Twitter. He showed us all the press release, and there's a really neat time lapse video that they put out for the whole construction. And what's cool is it took them about a year to build this facility. And up until a month ago, it was a 200 megawatt facility, 1 hour. So it's a 200. And then as the things were happening, they pushed it and sort of kind of tossed in an extra 30 megawatts. And it was just kind of neat to hear about that. And by the end of the month, this will reach the full 250. And so it's just kind of cool to see the quickness, the nature of energy storage and how it's deployed. Again, this is a battery that is a building. So you look at, it's just a structure on the outside, a giant shipping container. And when you look on the inside of it, you just see these double stacks of battery banks that look like data center hardware. They're probably all centrally made in a factory, and they just have 1, 2, 3, 4 wires in the back that you plug in. And so they deploy quickly and cleanly, with the majority of the hardware construction occurring elsewhere. And the quick piece, I think, is something that's going to catch a lot of people off guard. We're going to be able to deploy energy storage so fast, much faster than anybody realizes, because it's just going to roll off manufacturing lines, and we happen to be experts at making manufacturing lines as human beings. So the energy storage industry is going to scale as fast as we allow it to. And I think with wind and solar needing energy storage and cars transitioning to energy storage, it's going to scale as fast as we need it to. Um, Benchmark Materials, they're a real smart group who does analysis of energy storage. I follow Simon on Twitter as well, and he, I think his last number said there's between 141 and 143 gigawatt gigafactories. You know, factories that can produce more than 1 gigawatt hour of energy storage a year. I guess that's what the definition is, and that's huge. I mean, the volume of batteries that we're going to make in the world is just gonna scale so fast. And this facility is now number one. It just kind of snuck on there. The number one prior facility was the Tesla battery in Australia, in Hornsdale. And so now we got a new big one. And this one eventually will scale. Next year, it's going to be a 3-hour battery, so 250, 750. And it has the possibility, with the structure and the infrastructure, to scale to an 8-hour battery. Cody mentioned this specifically when he was talking about it on Twitter. So a 250, 2 gigawatt hour battery potential in this particular site. That's pretty cool.
Yeah, I mean, one of the cool things about batteries is, you know, once you've got all that infrastructure in place, and as the technology evolves, then you can upgrade the facility, because those battery packs or modules can be swapped out, and we're going to see that too. Lots of repowering as the technology gets better, the duration of the battery gets longer. So it's very early days for lithium ion, really. I mean, Tesla was on the bleeding edge of that, right? And now it's going mainstream. And in 10 years, everybody's going to have a battery in their garage. Every building is going to have a battery in their mechanical room, because it just makes good sense and it makes good business sense. So it's pretty exciting to, you know, 3 years ago, I wasn't talking about storage every day like I am now. You know, things are very different than they were 3 years ago, and things will be very different in 3 years. So I'm excited to see how that changes.
You know, with that change and that thought, that's and the fact that really one of our goals here is to give information for people that's usable so that they can make some good decisions. As a financial guy, I'm a developer, so I look at spreadsheets and I have to talk to people about the numbers of their projects, what it means for them, electricity generation, tax benefits, whatever the other variables, operations and maintenance costs, everything going into that spreadsheet. One thing that I think business owners and homeowners and whoever's considering buying a battery, they should add to their equation is, what is the value of having electricity 24/7 for you? You know, for me, as a person who has a small place and a relatively simple life, I'm just saying this for, sake of conversation. If I were to lose power for a few hours, I'd be cool. It wouldn't be a terrible thing in my existence, because, my fridge I'd keep closed. I can walk down to the gas station to get some food. Life wouldn't be a challenge for me. If I had a business though, with 50 employees and refrigeration and people coming in and out, customers buying things dependent, what's that worth? And that has to be calculated prudently, smartly, not too much. Don't get aggressive with it. But I remember a document I reported on a few years ago from the Energy Storage Association, the ESA, and they valued the downtime of business in America relative to number of hours of electricity loss and just a bunch of calculations. And it wasn't a trivial number. It was in the tens of billions of dollars of lost productivity per year for power outages. So if you're a business owner and you're trying to consider, should I get a battery? Well, don't look at extreme happenings like is in California, because that's extreme. look at just normal every day. Does your power go out once, twice a year for 10 minutes, for an hour? And what are the costs? And this way, when you see the spreadsheet for solar and storage, you can add a new column to the spreadsheet and just give it some thought. Let it percolate and be like, and if it doesn't affect you guys, if you can deal without it, then great, continue on with life. Life is solid. But have that piece of information in your head because it'll help you make your decisions over the long run. Because, you know, this is another piece of your structure. It's, you got lights, you got air conditioners, and one day you're going to need batteries. That's just seemingly how it's going to work. So,
Yep. Well, as we mentioned, about upgrading technology, the solar technology is also evolving. We now have what's called bifacial solar modules, and you tweeted about a story about the decline in the cost of bifacial modules. So for our listeners, most solar modules are producing power from the side of the module that faces the sun, and then they have a white backsheet that blocks the light actually from the solar panel. But now industry has invented these bifacial modules that can collect solar on both sides of the module, so the front and the back side. And so you're catching light that's bouncing off the ground or the roof and then reflecting into the back side of the module and producing power. And the rule of thumb that I hear is you can get a 10 to 15% bump in the power of the module that way. But what was the story about that you wanted to highlight? And I'll bring that onto the screen, John.
yeah, so it was a document written by either an engineer or a developer who was looking at bifacials, and he covered two things within the article that I thought were interesting. The first is that graph right there. It's the cost. The cost of the product is it was within a penny. I mean, that's the 24 cents for standard modules, and you know the same price, 26, 25 cents for a base bifacial, but that bifacial is the same price as a high efficiency product. And so, what we're seeing now is that this bifacial product, which is almost the exact same panel minus that back sheet you're talking about, it's now getting cost competitive with a standard product. And it should be. There's really no reason for it to cost anything different. Maybe to have a little bit more glass versus the plastic back shield. And so that'd be an extra penny, half a penny. Okay, sure, I'll let it have that. But we'll see how that evolves. DuPont has a clear plastic back sheet for their bifacial. So maybe we won't need extra glass and extra weight. But what this is, it's a more efficient solar panel. And if it costs the same, then why wouldn't you get the more efficient solar panel? And so that's really what it comes down to. It's the same product that almost exactly the same. You make one little tweak to it, and you can now get anywhere from 3% to 39%, which I thought was the cool thing about this article. The gentleman in the article said 39% in a perfect world for a bifacial optimization. I have never seen a 39% number for peak bifaciality or bifacial output increase. I've seen anywhere from 10 to 25, 10 to 30, but 39, that's just a big jump. And so when I saw that number and that price graph, I was kind of like, yeah, because I'm a big fan of bifacial, and I think there's still an untapped market in one area due to lack of data. Right here, what you're showing, this is Soltech. We have a single axis tracker in 2P formation. You have two modules in portrait format, and they're bifacial. And that bifacial is going to catch the reflection off the ground. And the tracker is actually going to optimize its movement based upon the reflection off the ground, because the machine is smart. It knows how to do some machine learning and analyze peak generation moments, and it runs numbers. But what also is going to happen are these people with white rooftops. And so far, I've only seen one bit of research, and that's from Prism Solar. They're a manufacturer of bifacial modules, and they put out a nice white paper on a bifacial, on a white TPO. That's thermoplastic. That's the white material that you put on a roof to cover them up. And guess what? A white roof obviously reflects more. It's the nature of physics. And so there's not been a lot of data on rooftop bifacial modules because the big players are going bifacial first. The ground mount people, the next trackers selling single axis trackers for the utility scale customer. And that's the big money. That's where the research is. But without a doubt, there's going to be a benefit from bifacial design on commercial rooftops. And Prism Solar has showed it with their documentation. A big bank recently did a white rooftop bifacial system. And so me as a CNI commercial guy for 75% of my work, totally looking forward to my first white TPO bifacial roof. I have one right now, a project I'm working, and we'll see. The modules have to be delivered sometime late September, early October is when we're going to have to go. And we haven't bought panels yet, but I'm going to try and nudge my contractor to go bifacial. We'll see if we do it though. But it's going to be a good market, and it's going to allow you increased panel efficiency, which gets greater electricity from your rooftop at nearly the same cost. And that's what the efficiency game is. So I like bifacial. I like all the whiz bang headlines.
Yeah, I mean, the bottom line is you're getting more electricity per square foot of solar array, right?
That's it.
Because you're capturing light from both sides of the module. We haven't installed any bifacials yet, so but we're in the Midwest, and the Midwest is not the earliest adopter. Even that site that I showed on last week's show of Nextracker, the 2-portrait Gemini project in Northern Illinois, they're not using bifacial modules on that project. And it takes time for these modules to percolate. I was talking to a manufacturer not long ago, about 9 months ago, REC Solar, well known more for the residential space than the commercial space, but they had actually dipped their toe in the water with bifacial and then backed out and stopped production, and now it's coming back again. So it ebbs and flows, and but it does appear that bifacial is getting traction now, and I agree with you that white rooftops are a great application. The challenge there for me psychologically is that most solar panels are at 10-degree tilt on rooftops, and that's to reduce the wind load on the solar array. You don't want it to kite off the roof, and you have to weigh it down with bricks, as we've talked about. It's called ballasting, or you do attached or a hybrid. You could do partially attached or fully attached. And you also referenced that tracker product that Point Load, I believe, is the name of the company, Point Load Power. And they're going to be coming on the podcast here in the next month or so. I think that application is quite compelling because the modules can be tipped at 30 degrees because it's an attached system. And then you're getting more light. But at 10 degrees is not a lot of slope. It's like this. And you can comfortably walk around on a 10-degree slope.
Yeah, maybe that low slope will let the light go through the bottom half of the module and then bounce and get into the top half. You're right. It's not going to be optimized. Everyone who has shown the research to me, the optimized angle is somewhere between like 6 feet and 10 feet for the height, because you want to catch it as it bounces off the ground. And they've done hardcore research for the ground coverage ratio, the distance between the rows, the angles that the modules are at, the season, the day. Nextracker, they have a software suite. Its broader name is called True Capture. And what it does is that it just watches everything. It watches all the variables and says, okay, when could we make the most electricity? That's the beauty of an intelligent tracker. On the roof, you're right. We're going to have to see how it comes out, but it's going to be something. And something is generally better than nothing. That's the sales pitch, at least.
Yep. So, speaking of this, these trends in the evolution of the technology and racking, I wanted to talk about this new racking product called Oojo. I'm going to put it on screen here in a second. There's an entrepreneur named Jack West who some years ago invented a rooftop racking system that he then um, patented and sold to uh,
Solar City.
Solar City, yeah, called Sept. And now he has, I'm going to share my screen here. Now he has invented a new ground mount racking system called Oojo. I don't know why he's calling it Oojo. I think that's a little bit funky, but anyway, it's a very different platform basically, right? Most ground mount structures are a monopile. You're just taking an I-beam or a C-channel beam and driving it straight into the ground and then mounting the array, as we saw in that previous photo of the Soltech tracker. I can't find that because
You got a lot of tabs open there.
yeah, my video interface interferes with my ability to see my screen. I'll get it while we're talking. But the premise of this they call it a truss design, right? The triangle is an extremely strong from just a pure engineering and physics approach, right? The triangle is an extremely strong structure. That's why when you see a bridge, there's lots of triangles in these truss bridges. And you see this in carports, in the solar industry also, and now it's coming to ground mount solar. And the idea basically is that you're going to have less steel, stronger, more resilient structure. There's tremendous downward pressure on pricing in our industry, right? Everybody is trying to get to lower installed cost, which then translates to lower long-term cost of energy. And so these innovations, who knows if Oojo will stick and be the thing, right? It might take 10 or 15 years to really vet it out and see if it's going to get traction. It does use a ground screw um, and or a helical pile, and so that is also advantageous in certain soils, like when you have very hard soils or very rocky soils, and you can't necessarily just vibrationally drive a pile. I mean, it's amazing to see, right? When you just take an I-beam and you just driving it straight down into the ground. And that works great here in Illinois. We have deep topsoil. It's basically very easy to drive, sometimes 15, 20 feet down into the ground.
Not
But
here.
yeah,
Not in the Northeast. We get a lot of rejections. And so we do a lot of ground screws up here.
yep.
Yeah, very different market. We get lots of rocks in the soil, very rocky in Massachusetts.
So from a ground mount perspective, though, in Massachusetts, John, what are the preferred racking vendors that you've seen?
I mean, there's lots of RBI solar. RBI's driving around a lot. They do a lot of great work. There is Next Tracker for single axis trackers on the ground. Pretty much every big name of racking companies in Massachusetts. It's such a good market for ground mounts. But
yeah. AP Alternatives is well known for their ground screw approach. Also, we like those guys. We've done a number of AP projects here in Illinois even, and it's kind of apples and oranges, ground screw versus driven pile.
yeah,
But
it's good. I got a recent quote from TerraSmart, and we got both because we told them we were unsure about the site. We hadn't done our ground analysis, and they're like, "Well, let's just do some piles and ground screws." And a company like TerraSmart, they'll also install the racking material for you. And so then they break down the costs on each piece, machine rental, rejection rates. You got to do a nice geotechnical analysis for them to ease the process, hopefully. But the hardware is nice. I like ground. I like racking installation. It's kind of fun to watch sometimes.
for sure. All right. Well, we are going to touch on SPI and maybe Excel if we have time. We've just got a couple of minutes left. Is there another story that you want to highlight, John?
Well, the only other story for this one that I'd bring up is Tesla's doing research, and it's an article I'm working on right now. I'm reading the research paper, but what's most interesting about it is it's battery without an anode, and when you remove the anode, the efficiency or the energy density of the product increases effectively about 60%, 43.7% less material. And I wanted to point it out because it's a product that's approaching 400 watts per kilogram. And that energy density has been suggested, and look at it, you can see it in the fourth line of the abstract: electrified urban aviation. Elon Musk, this guy who does this stuff with cars and batteries, you might have heard of him. He recently said, per reporting by electric.co, that at 400 watts per kg, you can get small airplanes. That's the start of it. They have a Roadrunner program, Tesla, and it's their research arm for their battery that suggests a path over 500 watts per kilogram. You know, I think, and this is how I'm going to start my article, I think we need to let go of what we think we know about what we can do with energy storage and shut up and let the technology go and start saying things like, what can we think about? Because we keep doing more than we said we could. The prices are falling much faster than we thought they were going to. And anybody who's respectable and smart, they would say you're not going to build a battery that can fly. Only gasoline can do it. Well, there's already airplanes that are only electric. And this guy, Elon, he keeps saying things that keep happening. So it's just yet another thing of research moving forward. We are progressing. We are the smart animals who figured out how to use fire better than anyone else. And this is cool. I'm still reading the paper. I'm just so excited reading it. Just 40%, the battery. Yeah, just great thing. I'll publish this article. I'll bring it up next week, and I'll show you some pretty pictures. I'm looking forward to reading the paper further.
I'm glad you brought up Elon Musk, because the main misperception about Elon and Tesla is that Tesla is an automobile company. Tesla is not an automobile company. Tesla is an energy company, and they are basically putting batteries on wheels, and then also installing solar in that, and that tripartite is very powerful. Batteries for storage, EVs for getting around in a clean, safe way, and then solar to take sun from the fusion reactor in the sky and store it, right? Or use it in real time. And Elon is now the fourth richest man in the world. It happened this week because the Tesla stock is taking off because of the 5-for-1 split. People, just the psychology of that gets people excited, even though the company hasn't changed in the last week. The stock is jumping because of this pending 5-to-1 split. It's a good thing that the stock is splitting, because right now it's like $1,800 a share, and that's out of the price range of many investors. So the 5-for-1 split will bring it down into the $300 to $400 range at least.
That's where it was last year. So, nice, normal
right.
price.
Yeah, just last fall, it was in the $300 range. It's quadrupled since then, or more than quadrupled, which is just crazy to think about. But anyway, Musk is a visionary. He is the visionary of our time, John. And like him or not, and he has his craziness, right? He does crazy things. So he's got that super smart, but also bordering on crazy stuff. Like naming his newest son some combination of strange characters that nobody can pronounce. I mean, why? Who does that?
People who have set themselves free of the simple rules of mankind.
That's right. So I'm glad I'm not Elon Musk's son, but anyway, I'm glad that Elon is here. I'm glad that he came to us. Another immigrant. Take note, immigrants make America great again. And he's from South Africa originally. But all right, so in the final moments here, a hard stop here in just a couple of minutes, but you know, we have a big trade show in our industry. If you're not in the solar industry, you don't know this yet, but it's called SPI, Solar Power International. It's usually in September, somewhere out west, either in California or Utah or Nevada. And first it was going to be in Southern California. Then they moved it to Las Vegas and said, well, we're going to make it outdoors because of the coronavirus. Well, lo and behold, right, people are realizing that the coronavirus isn't as easy to step on as we thought it was. And so now SPI is going to go pure virtual. I'm going to share my screen here. And I think this is a good thing. It's a challenge. I participated in a virtual conference earlier this year called.
What'd you think about it? How'd you pick up stuff? Did you
Yeah, so that
like
was
it?
the Midwest Expo, which was
Mhm.
is a solar conference traditionally in Minneapolis, and it was useful. It was not as well attended as the real conference was, last year and the year before. So that's, people are timid about going virtual. It does have its quirks. In this case, um, they teamed with Jake Rosemarin at Antenna Group,
Mm-hmm.
and they used a virtual 3D
Okay.
technology so that you create an avatar and then you run around and there's a trade show. And I didn't necessarily go for the whole avatar thing, but I would rather just be able to have like a video chat with somebody or an audio chat with somebody. But anyway, you were able to interact in real time with people and attend talks, and so they did reinvent the conference experience. I'm not sure what technology SPI is going to use, and but it's going to be completely virtual. I mean, this is a conference that attracts a couple of tens of thousands of people. It's a ginormous event,
Yeah.
and the trade show is so large that you can't see everything in the trade show, right? It's too big. Um, there's a dedicated section for storage and microgrids,
They had
and
hydrogen at the last one.
yep. And so anyway, I look forward to I will very likely attend this, and you know we have to try
Yep.
because that is the nature of the new economy, that we can't do as much stuff face to face until we get a vaccine. And it was encouraging that there was some news about the corona testing. The University of Illinois has invented a saliva test for coronavirus, and which allows much more rapid testing, and it's also less invasive for the subjects. Right, you just put a little piece of a little drop of spittle on on something, a piece of cotton or something, right, and then away it goes. You don't have to get a swab jammed up your nose, which I've
It wasn't that
had.
bad. It
Um,
wasn't that bad for me. Whatever. It was 10
I thought
seconds.
it was pretty painful.
Nah.
I'm not in a hurry to have that done on a weekly
Oh,
basis. And that's the thing, is these colleges really do need to do testing on a weekly basis, because they got to step on the infections that do occur so that they don't get out of control. And many people don't have symptoms,
hmm.
right? And that's the real risk, right? Is that people are spreading the disease without knowing it. And, and nobody wants to get corona. It's a killer. So, well, John, thank you so much. I really appreciate all your input and geeking out on storage. I love it. So, where can people find you?
If you type in commercial solar guy into Google, you'll find me on about 15 different web pages: Instagram, Twitter, of course, my website, commercialsolarguy.com. I like LinkedIn. All over the tubes, you can find me. But LinkedIn and my website and Twitter are the most active places. A lot of news on Twitter I share.
And what markets are you very focused on right now for solar?
Super focused in Massachusetts, Rhode Island, slowly expanding into New York, Pennsylvania, New Jersey, a little bit in Vermont, touching on Maine. So mostly in the Northeast, and then, random phone calls from all over the nation because people find me. So I have 4 or 5 projects in California. I got 1 or 2 in Texas, a couple up and down the East Coast. So as they come to us, but I reach out aggressively in Massachusetts and Rhode Island, because those are my super local markets within a 30-40 minute drive. And I'm covering all of Rhode Island and the Southeast Massachusetts region.
Wonderful. I'm Tim Montague. You can check us out on YouTube. Just Google CES NRG on YouTube. And you can also find me at cesnrg.com or TG Montague on Twitter. Well, that's another episode of the Clean Power Hour. Thanks for listening, and you have a great day, John.
You too, Tim. Bye-bye.